Good morning, everybody. I am your chemistry teacher, Sahla. How are you? I hope you are fine. Here, let me introduce our chemistry 10th chemistry textbook that has two parts. First part consists of 4 chapters, second part consists of 3 chapters, altogether 7 chapters. Then the first chapter titled as Periodic Table and Electronic Configuration. First, we can fresh up the previous knowledge about periodic table. Periodic table is the table of elements. Here, elements are arranged in the ascending, that is the increasing order of atomic number. Atomic number is the unique identity of an atom or an element. Atomic number is equal to number of protons or number of electrons. Then periodic table consists of horizontal rows and vertical columns. Horizontal rows are known as periods, vertical columns are known as groups. Then we already discussed about the various atomic models. Here we studied Thomson's plum pudding model, that is plum pudding atomic model, then Rutherford's atomic model, then Niels Bohr's atomic model. The suitable atomic model here is Bohr's atomic model. We know an atom consists of 3 fundamental particles. First one, proton having positive charge. Then neutron having no charge. Then electron having negative charge. These fundamental particles are arranged in Bohr atom model as proton and neutron is situated at the center. This center is known as nucleus. Then the electrons are revolving around nucleus. Electrons are revolving around nucleus. These paths for movement of electrons are known as shells. These are known as shells. It may be called as orbits or energy levels. Here, first shell, that is very near to nucleus, it is first shell, it is termed as K. Then next shell is second shell, it is termed as L. Then third shell is then M, then N, etc. In Bohr atom model, at the center nucleus, we already said, in shells the electrons are revolving, but the energy of the electrons are different, because when the distance between nucleus and shell increases, the energy of the electrons also increases. That is, the electrons in first shell has low energy, but the electrons in last shells have high energy. Therefore, shell is also known as energy level, because each shell consists of definite energy electrons. Then, in a shell, maximum number of electrons are maximum number of electrons in each shell is accommodated as by the equation 2n square. Here n is the shell number. For example, in first shell, that is in K shell, the maximum number of electron is 2n square, that is 2 into 1 square, that is 2. In second shell, that is L shell, it is 2 into 2 square, that is 8. In third shell, M, 2 into 3 square, like that, that is 18. Therefore, in an atom, the electrons are situated as 2, 8, 18, etc. This is the shell electronic configuration. That is, shell electronic configuration is the arrangement of electrons in each shell. In first shell, there is maximum number of electrons is 2. In second shell, maximum number of electrons is 8. In third shell, maximum electron is 18. This configuration of electron is known as shell electronic configuration. Next topic is subshell and subshell electronic configuration. Subshell and subshell electronic configuration. Actually, subshell is the sub-levels of shell, that is principal energy levels. Sub-levels are subshells. Subshells are termed as S, P, D, F. Each shell consists of subshells. The number of subshells is equal to the shell number. For example, in first shell, that is in K shell, the number of subshell is only 1, it is S subshell. But in second shell, that is L shell, the number of subshells are 2, that is S and P. In third shell, it is M, the subshells are S, P, D. Then fourth shell, the subshells are S, P, D, F. Above fourth shell, the maximum number of subshells are S, P, D, F. Each subshell consists of, that is in S subshell, the maximum number of electrons are only 2 electrons. But in P subshell, the maximum number of electrons are 6 electrons. In D subshell, maximum number of electrons are 10 electrons. In F subshell, maximum number of electrons are 14 electrons. To identify the subshells in shells, that is, we know in K shell there is a subshell. In L shell there is also a subshell. In M shell also a subshell. To identify the S subshell in which shell, it is indicated as 1 S or 2 S or 3 S or 4 S, like that. 1 S means it is the S subshell of first shell. 2 S means S subshell of second shell. 3 S means S subshell of third shell, like that. That is, the number in first one is, first number is the shell number, then S subshell, like that. What is this 2P? 2P is the P subshell of second shell. What is 3P? P subshell of third shell. Then we can write the subshell electronic configuration. We already said that first shell is the 1S. That is, first shell consists of only S subshell. Second shell consists of S subshell and p subshell. Third shell consists of 3s, 3p, 3d. Fourth shell consists of 4s, 4p, 4d, 4f. Fifth shell consists of 5s, 5p, 5d, 5f. Then electrons are filled. We know electrons are filled in the increasing order of energy. Therefore, first electron is filled in 1s. After filling this 1s, the electrons are going to 2s. After filling 2s, the electrons are moved to 2p, then 3s, then 3p, 4s, then 3d, 4p, 5s. That is, electrons are filled in the order that is 1s, 2s, 2p, 3s, 3p, please listen, 3p, then 4s, then 3d. What is the reason for this type? Because the energy of fourth S subshell is less than energy of third D subshell. Therefore, electrons are filled like that. That is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, etc. Then, we already said that the maximum number of electrons in S subshell is 2. Then we can written as 1s2. Again 2s2. Then 2p, how many electrons? 6, because maximum number of electron in P subshell is 6. Then again 3s2, 3p6, 4s2, 3d, how many electrons? 3d 10, because D can accommodate maximum 10 electrons. Then 4p6. This is the maximum number of electrons then the subshell can accommodate. Then we can write the subshell electronic configuration. For example, hydrogen having atomic number 1. Hydrogen having atomic number 1 means hydrogen has only 1 electron. Its subshell electronic configuration is 1s1. Then another example, magnesium atomic number 12. Then how many electrons? 12 electrons. Then its subshell electronic configuration is 1s, 2, 2s, 2, 2p, 6. Then how many electrons? 2 plus 6. Here 10. Then 3s2. This is the subshell electronic configuration of magnesium having atomic number 12. Then another example, chlorine 17. How many electrons? 17 electrons. We can write as 1s2, 2s2, 2p6, 3s2, then 3p, how many electrons? 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, then 5. 1s2, 2s2, 2p6, 3s2, 3p5. Then this is the subshell electronic configuration. Then another example, scandium 21. How many electrons? 21 electrons. Then we can written as 1s2, 2s2, 2p6, 3s2, 3p6. How many electrons? 18 electrons, remaining 3 electron. Then next electron is filled in 3d or 4s. Yes, 4s, because 4s has low energy than 3d. Then first fill 4s, then 4s2, then last 3d1. This order is subshell electronic configuration in the order of increasing of energy. Increasing of energy. Then we can conclude the subshell electronic configuration. When we write the subshell electronic configuration, must care about these numbers. That is, the number in the left side of the subshell is which number? Shell number. That is, 1s means the subshell of first shell. Here shell number is 1. Then this number above the subshell, that is S, is 2. Here this 2 indicates the number of electrons. From this example, we can understand that 1s2 means 1 is the shell number, first shell contains S subshell. This S subshell contains only, that is S subshell contains 2 electron. What is meant by 2p5? 2p5 means, here 2 means shell number, that is second shell. P means the P subshell of second shell. This consists of 5 electrons. Then I stop this topic, subshell electronic configuration. Then do the assignment, that is write the subshell electronic configurations of elements having atomic numbers 1 to 30. 1 to 30. Example, first atomic number, the element is hydrogen. Then its subshell electronic configuration is 1s1. If second element, that is helium, having atomic number 2, 1s2, like that. Please do the homework in time. Thank you.